Hello and welcome to another video. In this video we're going to be working on word break 2. And in this one you're given a string in a dictionary and spaces in a string to construct a sentence where each word is a valid dictionary word. You return all such possible sentences in any order. So essentially what you're doing here is you have a dictionary of words you can use and you have a word. And you can break your string into valid words. So one way to break it would be like this: cats and dog. And then you would return cats and dog for that one. You can also do cat, sand, dog, and those are the only two. And then we have pineapple, pineapple, and there's a couple ways you could do that as well. So, and then for the third one, there are no ways. So we're going to do this doing the backtracking template that I've been talking about, and some people ask, like, what's the backtracking template? So I'll go over it in detail again. Basically, the backtracking template is you have a couple things. You have a result, some kind of result variable that you store things into. In this case, it's going to be our array. And you have a current, which is like a subset, or your current subset that you're building, which is like an array or a string or a number or whatever. Result can also be like whatever. And then in your actual backtracking function, you have two cases. You have we are done. And if we're done, then you just take your current array and you put a copy into the result. So put current and result. And then otherwise, and you would return here. And otherwise you would like do some other stuff, either loop or have an item and take or not take it or whatever, right? So basically what happens down here is we say we choose to take an item. Then we backtrack, then we get rid of item, and then we backtrack again, right? So we basically choose to take something, choose to make some kind of decision, then we backtrack, then when we come out, we get rid of what we chose, and then maybe we backtrack again, maybe we don't do anything. This is kind of like optional, but that's kind of the thing. And you might be able to choose, there might be like a lot of items to choose, but that's basically it. So essentially you're building a subset, and every time you build a subset, when you put in some valid thing in there, you recurse, and then when you come out, you just take your item out of the subset. So you're essentially reusing one subset and building your result, and that's backtracking template. So what we can do here, and there's like a few ways to do this problem. So you can do it either using backtracking or DP, or try with backtracking or DP. So basically try, like, I guess I'll say it's more like you can either use backtracking or DP, but for your storage. So what we're going to want to do is when we're going to want to split, we're going to only want to split into valid words. So here we want to think like, well, we can say like we can try to put a letter into a new word or a current word, but that wouldn't be super efficient. So instead what we can do is we'll just try to split, like let's say we start here. We'll just try to split at every index. And then in order to split, we have to check if the word's valid. So let's say we want to split like this. We have to check like, is cats in our word dictionary? And an efficient way to do that, there's one of two ways, right? So there's either a set. So we can take our words and turn it into a set. And then when we have a word, we can efficiently check if it's in our set. Or a try. And I'll briefly talk about like why a try would be better in some cases. In this case, I don't think a try adds much. But essentially, let's say we have cats and dog. So if we have cats and dog, and we just start over here. So we're basically going to say like, okay, maybe we'll try to split like this. And if we try to split like this, we have to build this string and then check if it's in the words set. And the way to check if a string is in a word set is basically you take the string and you put it and you like check if it's in there. But I think like you have to hash the string to a value, which is like O of n, and then you have to see if it's in your bucket and so on and so on. So you have to build it and then you have to check if it's in there. So it's kind of slow. So basically like if we want to split here, we'd have to build this string. Then if we want to split here, we have to build this string. Then we have to build this string. So we can't just like keep adding a letter, right? We can't just have like, okay, maybe we'll have like cat, and then we'll add like an S. No, we have to like rebuild the string every time. So every time we have a new word, we have to rebuild the string, which is like not the best. But for a try, you can store your words, and then you can just traverse down your try. So moving from like this state to this state is actually just O of 1. So moving from, each one to the next one is O of 1. And a try is useful when your word dictionary is like, when your words are kind of big. And when you have a lot of them. So we do have a lot of them, but we can have a set, which is fine, because like it doesn't take us long to build the word. So because the words are only like 10 characters, it's fine. But if the words were like 1,000 characters, then it would be really inefficient to have a set of words, because first of all, it would be really big. Second of all, in order to build a word, it's O of 1,000. And in that case, we'd want to use a try. So in this case, we're going to use a set. It's simpler and the words are small. But as your words get bigger, then you're going to want to use a try. So essentially what we're going to do is going to be pretty simple. We're going to have like the current array. So in this case in Java, we're just going to build up a string with a string builder, which is basically an array. I think under the hood, I'm guessing it's like a stack or something, because I don't think it like builds strings, because strings are immutable. So I think a string builder is basically just an array. So essentially we're going to build strings. So we're going to say, like, for example, if we start here, we're going to say like, okay, can we split like this? Well, there is no C in our thing, so we can't do that. Can we split like this? No. Can we split like this? Yes. So we'll put cat in our current thing. Then we'll recurse over here. And then we'll say like, okay, so we're done with all this. Right, so basically we're done with all that. Now, where's our next split? So can we split like this? No, because S is not in there. Can we split like this? No. Can we split like this? No. But we can split like this. So this will be our second word. So we'll put in sand here. Then we'll recurse over here. And then dog will be the last word, so we'll put in dog. And then we'll have a string of cat, sand, dog. So we can, that'll be our first solution. Yeah, that'll be our first solution. And the word doesn't matter. Then what's going to happen here is we're going to recurse back to this state, and we're going to say, okay, so we took this. Now let's try. So in this case, there's no other ways to do it, right? Because when we start here, the only valid word is dog. So we're gonna actually come back here, and then we're gonna say, okay, let's pop off the dog, and we can't get anything else. So now we'll actually come back here. We'll actually come back here, and we took the sand. So now there's no other word because there was only sand. So we're gonna pop that as well. But now for cat, so we took cat here, but we started here, and we took cat here, but we can also split like this. So we're gonna say, okay, let's try this way. So if we split here, we're gonna recurse to this state, and then and will be a word and dog will be a word. So we'll have this other one. So essentially it's backtracking because we'll just start at some index, let's call it this index, and then from whatever index we start to the end, we're gonna build a word, and we're gonna keep checking, is that word in our result? So we'll try to build like this, then we'll try to build this, then this, then this, and so on. And if it is in our result, we will add it to our stack, and then we'll recurse to like the next letter. And basically a valid split is when you manage to get to the end, because that means you were able to split the whole thing. And for every valid split, we're just going to put it in our result with backtracking. Okay, so let's do that. So the same kind of thing for the template. So we'll have, if you want to have a result variable, so in this case, it's going to be a list string. And you want to have a current variable, which is going to be the variable you're going to be using to modify your subset. And this just needs to be a string. No, it needs to be a string builder in this case. You can use like an array as well. You don't want to use a string because using a string is not the best. Because when you add strings to strings, you have to like rebuild the string. So string builder is more efficient. So this will be cur. Okay, so now we're going to initialize our result. And cur equals new string builder. And so now, just like all our other stuff, now we just have to call backtrack. And what do we have to pass to our backtrack? Just the index we're at, so 0. And we have to give the string that we're going to be like going through. And there's one more thing. So let's actually make another class variable called words. And this is going to be a set. Because if we have an array of 1,000 words, it's not going to be efficient to find if a word is in here, right? So we're just going to turn this into a set. Now, one thing you can do, I don't know if it'll be more efficient, probably not, is instead of having a set of words, you can have a dictionary of words, and you can have every word mapped to an index. And then instead of storing like a whole string in your current, you can just store numbers and then like join them at the end or something. I don't know if that'll be faster or not. Maybe not. But anyway, so here we need to just turn our word dict into a set. So we'll say words equals new hash set. And I believe you can just pass this into the constructor. Okay. So we're going to backtrack, and then we are going to return the result. So if you actually look at all my previous problems, it's almost always like this, right? You initialize a result to 0 or whatever. You initialize your current to something. You call backtrack, and then you return the result. And now we just write our backtrack function down here, just like pretty much all the other ones. So what do we need for the backtrack? We need an index, and we need the string. So like I said, in the backtracking template, the first thing you check is, do I have my base case? So if I equals s length, that means we were able to split it correctly, and our subset is stored in cur. So we just need to take cur and put it in the result. So we can say result add cur, and then the string builder has a toString method that we can use. If you're doing this in Python or something, then just cur, instead of using a string builder, use an array of words and then do a join at the end, which works as well. And I'll show you that in a second. So yeah, so we just do this, and then we just return. So now what we want to do is we want to loop from every single, we want to loop from our starting index to the end of the word and check, is that substring a word in our word bank? And if it is, we'll try a split there. So we can say for in j equals 0, j is less than s length. So we're going to get the word. So we can call this like word equals s ij plus 1. And we're also going to record, I mean, you probably don't have to, but this is one of the ways to do it. We're going to record the length of our string builder, because we're going to add a string to it, and then to delete it, we need to know how long it was originally. Yeah. So let's do that. No, I mean, you can calculate it on the fly. You can calculate it on the fly by doing like its current length minus the word, I guess. That would be another way, but it's going to be kind of messy. So let's do it this way instead. So we'll say int builder length equals string builder, or not string builder, cur length, I believe. Okay. So this is like the starting index of where we need to delete from. So I think, like, let's think about it, I guess. If we have a string builder of 5, that means we have 0 to 4 filled up, right? So we'd have like this. And then, yeah, the next letter we'd want to delete starts at index 5. Yes, that's correct. Okay. So now what we want to do is we want to check. So we actually don't need to do this every time, so we'll put this in an if statement. But we need to basically check if word is in our hash set. So if it is, then we need to do the recursion. So this is going to be words contains, I believe. Yeah, so if the word contains the word, then we're going to have all these things. So this needs to go in there. And then what else do we need? We need to actually put the word in our string builder. So we'll say cur.append. So we need to do one more thing, because in Python you'd have an array of strings that you can join. But because we're actually building a string here, so you want like A space B space C in this kind of format. So we basically need to check, like, if this isn't the first word in a string builder, we need to add a space. Yeah. Okay. So let's do that. So we can say if builder, let's see, actually what's our builder? Cur is not empty, then we need to add a space. Oops. So we'll add a space there. I believe you can add like a string or a character. Yeah. Okay, now we need to add the actual word. So this is going to be word. Then, like I said, for the backtracking template, first you have your base case. Then you have your case of taking the item. And then, so actually in this case, it's going to be a little different, right? Because you kind of have two cases generally for these. You either have a take or not take for the index you're at, but that's not going to be efficient here because we don't want to just like take or not take a letter. So instead, we're looping through every single word possible, and then we're choosing to take that word. or not taking that word and trying another word. But you have to take some word to do the split, right? You can't like backtrack without taking a word because you have to actually split into words. So this will just be current append. Then we do the backtrack. And this will, so if our word is from I to J, then it means we want to backtrack to J plus 1. And then we want to pass down S as well. This needs to be void. And then, so now that we return out of here, we need to make sure that we undo what we did, right? That's the whole point of the backtrack. So we're going to pop the word. And this is why we needed to save this, because this doesn't have like a pop word. It has a delete. So you can delete from a start index to an end index, and that's why we needed it, because we're not using like an array. With an array, it's easy. You just append and you pop. In here, we actually need the start index to pop from. So this is going to be from this thing that we stored originally, builder length, right? And it's just going to be till the end of the string builder, so everything until the end, like this. Okay, so essentially we pop our word, we pop our space if we had it, yeah. And then that's all there, I believe. So essentially we're going to try to build every word we can, we're going to try to recurse everywhere we can, and then this will give us all our combinations, and then this should be it. So let's see if we missed anything. I guess let's take a look at the errors. So out of bounds exception. Oh, this shouldn't be the 0. This should be I. Okay. And there we go. So runtime for these, I think I found that runtime for backtracking is kind of the hardest to estimate. And also for all these different solutions, right? Like, if I use a try, like, how will that work compared to a set and all these things? It's kind of hard to estimate, in my opinion. And it also, I guess, depends on the LeetCode test cases. But let's try it. So essentially, if you think about it, for the word, we have the option. So, well, I guess worst case scenario, right? Let's just think of, like, what would be the worst case scenario? So the worst case scenario is our word is actually something like this. I mean, it can be a bunch of different things, but basically the worst case scenario is our word can be split into one letter like this, right? It can be split into any combination. And let's say all of these exist in our word bank. So our word bank has like 1A, 2A's, 3A's, 4A's, 5A's, and so on. So that would be the worst case scenario, in which case you can kind of do any split you want, right? Like and you can split anywhere. So if you think about it there, at every single index, you have the option to split or not split. Right, so we can split here or not. We can split here or not, here or not, here or not, and so on, which is 2 to the n. Right, so yeah, so you have the option to split or not split. Plus, you have to build the actual words, which it's hard to say how costly that is. So, like, I don't think the time depends on the word dict length. But it depends on how many words in the word dict actually match this. Because if this is like a billion, it's still fine. I mean, I guess technically you do have to take every word in word dict and turn it into a set, so we do have to add that. So we'll say, like, let's just say characters is like the total characters in word dict. That's how long it'll take it to turn it into a set, something like that. But then as far as like actually building each word, I mean, obviously the words are like 10 characters, so it's basically non-existent anyway. So we can say this is like constant pretty much, because it's like, yeah, so we can say it's constant. So essentially you have the choice to split on every single index in your actual string, and then it's constant time to build the word, you can argue, I guess. And then you also have to build the set. So it'd be something like this. And then space. So you do have to build this dictionary. So that's going to be like O of characters again. And then let's see what else. So the string builder, worst case scenario, is going to be O of S. Yeah, so it's going to be like O of N, I guess. Because you can't have more characters to split the word into than are in the word. And then as far as the recursion, worst case is also O of N, because like I said, if you just keep splitting into one letter at a time, it'd be like that, which would be O of N. Yeah, and I think that is basically that. It's pretty hard to get these time complexities right for the backtracking and like the space, because like it's kind of confusing. But yeah, I think it's something like this. So essentially, I guess worst case scenario, imagine if instead of writing it this way, like I think this is going to be the same kind of thing. Like I guess worst case scenario, right? Imagine if every word was in here, like that thing I showed you, then you would basically be splitting at every single index. And then if you were splitting at every single index, then you kind of have the choice of every character to take or not take, and then that would be 2 to the n. So that would be the worst, I think. But yeah, regardless, so that's going to be all for this one. So you can see, like, for these hard problems, it's not super hard to do it this way. If you want to challenge yourself, you can do this using a try. It's going to be harder. You can also do this using DP in a try, which is going to be harder as well. But this backtracking solution is the easiest. I don't know, like, how, like I said, it's very hard to estimate the complexity of, like, the DP in a try or things like that. Yeah. But you can try it that way and see which one works better and like which one's faster. But definitely you should be able to figure out like when a try is better or not. And like I said, I think for this a try isn't super useful because your words are pretty short. But once your words get, like, if this was, you know, 1,000,000 characters and these were like 1,000 each, then it would be a lot better. Or like 500 each or whatever. But yeah, that's going to be all for this one. If you liked it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.